For this week's assignment, we'd like you to do the oscilloscope lab. If you'll go into Canvas, click on the oscilloscope lab, open up this document, come over, file, make a copy, and then work off your copy. For much of this, we're going to go ahead and give you some of the information because you may not be able to use the oscilloscope, but if you can, you ought to go in and play with it, and I'll show you how to do that here in just a minute. First thing we're going to do is, so you'll click here and there, and then it will bring up this oscilloscope, and we'll come back to that in a second. But first, we're going to give you 3 frequencies. So I'm going to do a demo here. This first frequency, 267 hertz. First thing we need to do is calculate what the period of this is. So if I jump in here and I say 200, well, first off, let's start with what our formula is. Our frequency formula is F is equal to 1 over T, where F is our frequency and T is the period. And we know the frequency here, and we need to calculate the period. So we need to come in and convert this. We're going to multiply both sides by T, so we get T times F is equal to 1. Then we're going to go ahead and divide by the frequency. And we're going to get that the period is equal to 1 over the frequency. We know that the frequency is 267.0 hertz. Okay? So let's pull up the calculator. All right, so first thing let's do is we'll just do this math. So we can do this one of 2 ways. 1 divided by 267. That's going to give us 0.037 seconds. So our period is 0.0037. Can't remember the rest of it. 3745. I'm just going to say 5. And this is in seconds. All right. But we can go ahead and convert that. That's kind of clunky. So if we go ahead and multiply this by 1,000, so times 1,000, that gives us 3.745 milliseconds. So 3.75 milliseconds. And that's our period. Another way to do this, by the way, is, and this is the way I prefer to do it, is 267, and then I hit this 1 over X button, and I get the same value, and then I'm going to go ahead and convert that back over to milliseconds, and I get 3.75 again. So it's the same either way. Okay, so 3.75 back over here, I'm going to say 3.75 milliseconds. Now, make sure you do the milliseconds. If you just type in 3.75, period is always in seconds. So unless you define it as something other than seconds, then, I mean, yeah, if you don't define this, then it is assumed that it's in seconds. So just know that. Okay, so now next thing let's do is let's go measure this frequency. So we're going to use the oscilloscope for this. You want this to be on the live input. I'm going to go ahead and unfreeze this input, and you can see me talking there. I'm going to go ahead and try and center this a little bit, center that a little bit. So now my wave's centered. As we look at this oscilloscope, kind of how it works, the gain just multiplies the input. So there, you notice my waves just got a whole lot bigger. Don't really need to worry about that. Just keep it at 1, and then your waves will be where you can read them. Seconds per division. That's your x-axis. So right now, every one of these big divisions, the big lines that cross all the way through on the x-axis is 1 millisecond. So from the center to the first right major line is 1 millisecond. Notice that as I go to 2 milliseconds, there's more waves on screen. So we just zoomed out. So now there's 2 milliseconds in between here, and then 5 milliseconds. And so on the 5 milliseconds, that means that each big division is 5 milliseconds. That means that each small division is 1 millisecond. So I'd have 0.1, 0.1, 0.2, 0.3, 0.4, 0.5. So each one's 1. On the 2 milliseconds, each small division is worth 0.4. So 0.4, 0.8, 0.1, third one is 1.2, sorry. Fourth one is 1.6, 4 times 4 is 16, so 1.6. And then we step up to the 2 milliseconds. Okay, 1 millisecond, that means each of these is worth 2, so 0.2, I mean, 0.2, 0.4, 0.6, 0.8, and then 1. Okay, so that's how that works. Volts per division, same thing. So here I have top to bottom, 0 at the origin, and then the first major line across is 5 volts. And I can change that to 10 volts. Notice that I zoomed out, my waves are smaller. And if I go to 2 volts, I zoomed in, my waves are bigger. We're going to go ahead and leave that on 5 volts for right now. Okay, and then I'm going to go ahead and do a tone, and once I do the tone, we can play with this a little bit more. So here we go with the tone. And this is the 267 hertz tone. All right. Now, if we did all of our calculations right, and if our tone is right, we should be able to match. So over here, 267 hertz, 3.75 milliseconds, and now we got to calculate our measured frequency. And this is how we do that. First, we come over to our oscilloscope, and I ask myself, can I get a complete wave on there? And yeah, I can. These waves aren't perfect. That's because they're coming from a source, from a tone source, instead of there's outside noise that's interfering. So I'm going to change this. Notice I'm going to come over to here. I'm going to try and match that here. That looks to me like that's about the same on the waves. So I'm putting this on my cross, or on my major division, and I'm going to change this vertical offset down to the line so that it's easier to read. So I'm going to go, we are on 1 millisecond division, so I can say that that's 1, 2, 3, 3.2, 0.4, 0.6, right around 3.8. So I'm going to say that we're 3.8 milliseconds. 3.8 milliseconds. All right, and this time we're trying to calculate the frequency. So we can use this formula directly. Okay, so we're going to go ahead and just plug that right in. So frequency is equal to 1 over the period. This is our period, except for it needs to be in seconds. So we're going to say, we're going to grab our calculator, 3.8. We're going from seconds to milliseconds, so we're going to divide by 1,000. And we get 0.38, or 0.38. This out of the way. So this is going to become frequency is equal to 1 over 0.0038 seconds. Okay, and this is looking pretty good because this and this are pretty close. So let's go ahead and do the math. Get the calculator back up here. And I'm going to go 0.0038. I'm going to use the 1 over x button. If not, you would have had to divided this number into 1. Oh, I messed up there. Hold on a minute. So 0.0038, 1 over x, there we go. And I got a number of 263.2 hertz. So over here in this right here, we would say 263.2 hertz. All right, that's how you're going to do this first section. We'll give you these, you calculate these, we'll give you the oscilloscope, and then you'll see that. So on this next section down here, we're going to give you an oscilloscope reading like this, and then, whoops, you're going to calculate your period and your measured frequency, and then your peak-to-peak voltage. So over here on this one, I'm going to go ahead, so each division is 5 volts. So you already know how to do the period and the frequency. Now we just need to do the volts. Now I've got a 5 volt division. That means that every small one is 2 volts, or 0.2 volts. Can I get 2? So now I'm just going to move this up on my vertical offset. And again, I kind of want to see if I can move this over. There we go. And then I'm going to move this up just, whoops, not horizontal, vertical. I'm going to move that right up to that division. So I've got 2 volts per division, so 2, 4, 6, right? I just wanted to get that a little closer so it was easier to read. So 2, 4, 6, 7, 6.1, 2, 3, 6.3. Let's do that again. 2, 4, 6 point. Let's see, 2 volts division is going to give me 0.4 on each one of these, right? 0.2, I'm sorry, 0.4, 0.8, 1.2. Yep, so it's going to be 0.4 on each of these. So 2, 4, 6, 0.4, 6.4, 6.8, just under 7 volts. So we're going to say 7 volts. There we go. So this is 7 volts. So back over here, peak-to-peak voltage is going to be about 7 volts. And that is how we do this second half. All right.